All right, here we're moving into section 5.5, and this is over completing the square, which is going to be our third method for solving a quadratic equation. Okay. Now, before I get to the method of completing the square, I first want to look at an example that's going to lead us into this method. Okay. So notice the directions here. Solve this equation by factoring the left side and using the square root property. Okay. So before we would have set our equation equal to 0 and then tried to solve it by factoring. These directions don't want me to do that, okay? And the reason they don't want me to is because the left side, this quadratic trinomial, is very special. This is a perfect square trinomial, which we talked about in an earlier section on factoring. Right? And if you recall, the great thing about perfect square trinomials is that when you factor them, the two binomial factors are identical. So in this case, that factors to x plus 4 times x plus 4. Okay? And since those are identical, I could rewrite this as x plus 4 to the second power. And then this is where the directions of using the square root property to come into play. So I can start to solve for x now by taking the square root on both sides of the equation. That's going to lead me to x plus 4 is equal to plus or minus 2 square root of 5. Okay, let's verify that. 20 is 4 and 5, and then 4 is a perfect square of 2 and 2. So right there's your pair that you can pull out. Okay, and then I would subtract 4 from both sides here. And that's going to lead me to x equaling approximately, or exactly, negative 4 plus or minus 2 square roots of 5. Okay. Now, we can get actual decimal approximations for these two numbers, so we have a more concrete idea of what our solutions are. So negative 4 plus 2 square root of 5 is approximately 0.47, and then negative 4 minus 2 square root of 5 would be negative 8.47. Okay? All right, so your first practice problem is set up very similarly to this example, okay? So I want you to pause the video and try to work through that. If you get stuck, of course, come back to this example, and then when you're all finished, come back and check your work with mine. All right, so these two problems that you've looked at so far, these lead us to the idea of completing the square, okay? So your square root property can only be used when your quadratic equation includes a perfect square trinomial inside of it, okay? So the first two equations in example 1 and practice 1, they were built perfectly for that, okay? They both already had the perfect square trinomial. Most equations aren't set up that way. So that's where completing the square comes into play. It's the process of creating a perfect square trinomial, okay? Now I want to use an applet to illustrate this, all right? And this applet uses algebra tiles, okay? All right, so down at the bottom you can see we have this expression of x squared plus 16x plus question mark. And the idea here is we need to figure out what numbers should be substituted in for the question mark in order to make this a perfect square trinomial, okay? So in the graph here, you see in blue, this blue square, it's supposed to be representing x squared, okay? And I can change the size of it, all right? Doesn't really matter. So how about I leave it right there? So understand that if that represents x squared, then each side length of the square represents x. So right here is a length of x, and then right here is a length of x. Okay? And then notice in the grid here, we have all of these little boxes, right? Each one of these boxes represents 1 by 1, okay? So now I'm going to move this slider, and what I need to do is take the x squared and I need to add 16 onto it. So that's what this slider is going to show. Okay. All right, so let's break this down. Understand that right here, think of this as one rectangle that is 1 by x. Okay, this length is x, this length is 1, so this is 1 by x, and notice I have a total of 8 of them here. 1, 2, 3, 4, 5, 6, 7, and 8. So altogether, these are 8x tiles. And then I have the same thing up here, another 8x tiles. So altogether, if you add those up, you have 16x tiles, right? So I have x squared added with 8x added with another 8x, which is the same as x squared plus 16x, okay? Now what I want to do is I want to complete the square here. I want to turn this into a square, okay? So the question is, how many ones do we need to add to make this into a square, okay? So basically, how many ones do I need to add here? And again, ones are representing by these little squares here. These are each 1 by 1, okay? So there's should be a total here of 64 ones to be added. Well, how do I know that? Well, if on this green tile right here, if that represents 1, so then I have 1, 2, 3, 4, 5, 6, 7, 8, and same thing here. So this is an 8 by 8, which gives me 64. Okay. So think about how this can lead us to an algebraic way of completing the square. Basically what we've done is we've taken this coefficient, or I'm sorry, this middle term of 16x, and we've cut it in half to think of it as 8x, all right, on each of these green spaces here. And then we take the side length of 8 and the side length of 8, we multiply those together, which is essentially like we are squaring 8, okay? So let's go back to the notes and we will kind of put this together. All right, so basically what we need to do to complete the square for any trinomial is there's 2 steps, okay? We need to cut our b value in half. And by b value, I'm talking about the coefficient on the middle term. And then we need to square the result from your first step. Okay, so let's complete the square and then factor each of the resulting trinomials here. Okay, so x squared minus 10x, I want to know what should I add to that in order to make it a perfect square trinomial. So again, the b value here is negative 10. I'm going to cut that in half to give me negative 5. And then I'm going to square that. Negative 5 squared is, of course, 25. All right, so that's the number that should be added in here. And that's now a perfect square trinomial, which factors to x minus 5 squared. Okay. All right, in the next example, your b value is negative 3. So when I cut that in half, it's not going to divide evenly. So I'm going to leave it as an improper fraction of negative 3/2. Don't use decimals here, okay? Use improper fractions. It's the way to go, because my next step would be to square it, and let me show the work here. If you're squaring a fraction, all you need to do is square the numerator and square the denominator. So that's the number that completes the square here. And then to factor this, I know it's going to become x minus 3 halves squared, right? And kind of give you a little shortcut on this. Whatever number is after x in your factored form, it's always going to be the b over 2 value. And I can verify that on the first example here as well. That -5 is the same as the b over 2 value. So it can help make the factoring a little bit quicker for you. Okay. All right, so you got a couple more examples on the Practice 2 tab there. Try those yourself, and then, when you're ready, come back and check your work with mine.